Am I back?
Yes, you're back.
Okay, great. Join audio. Okay. Okay, so I was saying, I'm just gonna minimize. I'm not okay. Yeah, so special courses you are doing. You have like the furnace, and you know the temperature for you to get you need to heat it. So let's say we're using gas to heat it, and you don't have the right supply of gas, so it means you will not get the required heat to get your moisture. So it's a special course. What are the common causes you can have with the moisture of my material, of my detergent or powder? What are the common causes that I have there? Yes, it could be the particle size. It could be maybe the time it spends on the belt before it gets into my pack. So these are so you know your special cause and one of the best way to do this is with the root cause. That's the cause and effect, to determine, oh, which one exactly is the reason why I'm having this variation. So yes, you have all the variations, the one that are within your specification, the variations that are within your specification limits. That's now I'm looking at your process control limits. Those are common. So it's just every other thing that is happening. But the one that takes it off the specification limit, I don't know if you can see my screen, because I want to show you with a graph.
Okay.
Let me try presenting again. Okay, I guess you can see. So the ones that are here, these are the common ones. So this could be particle size, this could be distance it takes from the conveyor to get to the machine. But when it goes to my red zone, of course, this variation is obviously from the heater, the filling machine. The nozzle is blocked, or it does not, the machine does not dispense at that point in time. This one could be small causes like my bottle size, my wrapper is not sealing properly and all of that. But your special cause are the ones that takes you off your specification totally. So those are the two types of variations that you have. There, if you look at this graph I have here, there's variation everywhere. There's variation, but they are within specification, so it's common, it's fine. But when you go outside the specification, that's when you go to the red zone, then you're already you're having like special causes, as the case would be.
Okay, thank you.
Okay, I thought I explained that somewhere here, but it's fine. Okay, any other questions? I hope we're able to appreciate at least how to use MINITAB to um, to analyze our data and all. I think that's the interesting part for me. Yes.
Yeah, Dom.
Yeah.
Hello, Dom.
Yeah. Hello.
Yeah, this is Kingsley. Thanks so much. Um, I've been using MINITAB for over a decade, and just give it another definition. So most of us are used to using MINITAB for CPKs and CPs, and then defining limits for your processes. But you give it another definition to show that it's not just for that. It's also things we can use in our day-to-day in-process checks. It's something we can use in our trends. And I just want to say thank you for your time. Thank you for putting things together. And in terms of the variables, dependable variables and independent variables, you can look at it from angles of raw materials versus the products. And you can also look at it from the aspect of process parameter settings versus the output from the process. I'll take, for instance, I'm mixing Nivea, for instance. I'm going to be mixing Nivea at the speed of 500 revolutions per minute. At that 500 revolutions per minute, what maximum temperature do I want to make sure I don't exceed for which duration of time? So when you bring in all those variables, you'd look at it from the process capability you're explaining, and then you could also break down these variables into their impact into the final product, the media product that comes out. Is it of the right viscosity? Is it of the right pH? All those things play around what you just explained. So I really appreciate the fact that you're able to break down the use of MINITAB in each of these applications. So a big thank you and kudos. More grace, more power to your elbow, bro.
Thank you very much. Okay. Yeah, so yeah, it's important to know what your dependent and your independent are, so you even know which approach to use. Okay. Any other questions or comments, or we can close? Adaku, were you able to install? I see she's on the call.
Hi Dominic. I wasn't able to, but I'll still try, and if anything pops up, I'll let you know.
Okay, so no problem. Maybe
Just
when I
since
share
you
this,
shared slide, yes, I'll work with it.
yeah. So if I share the slides, we'll go through the slides, and you just follow the process and see how easy
Thank
it
you.
is. Okay, thank you all. Thank you very much for joining. Yeah. Okay, bye.
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 Thank you so much, sir.
Bye. Thank you so much.
Bye. Thank you so much.
Many thanks.
Thank
Bye,
you.
Dom.